Okay, question for the Polar Conics worksheet number 36. Right? Just somebody said I was having a little trouble with this. Now, first of all, there's a typo. It's to show that the polar equation of the hyperbola is this other one. So, and hopefully that doesn't, that makes sense to you, considering that is a hyperbola equation, even though the wording says ellipse. Okay, so we need to switch it to polar version. So I remember that x is equivalent to r cosine theta. Okay, and it's squared now because x was squared, and y is equivalent to r sine theta, so again squared. Okay, and I'm going to try to get r by itself, so how about I multiply everything by, just get rid of the fractions, multiply everything by a squared b squared. And so that's going to make this r squared. Actually, first of all, let me factor out the r squareds. Okay, because I'm trying to get r all by itself, I see that. I'm going to put these two together. Not very often I make a common denominator, but I'm going to do it here. Okay, and now I can bring that to the other side. Okay, so and I have b squared cosine squared theta minus a squared sine squared theta. Okay, so, well, I have the left side all done. The left side has r squared by itself. So let's take a look at the right side here. All right, the right side, I see that there needs to be no sign. So I'm going to replace the sign here with 1 minus cosine squared. Okay, so that's going to give me from my denominator b squared cosine squared minus a squared plus a squared cosine squared theta. Okay, so, and now would be a great time, I think, to divide, actually, we have those two together. So I'll put that out in front, and I'm putting that out in front because I can see from what I want the cosine squared to be second, so I'm gonna factor that out. So if I'm looking at it there, I'm gonna have a squared plus b squared there. Okay, and so that's great. I have that. Now let me factor. Let me divide everything by a squared because I just want this to be b squared. Remember, this numerator just needs to be b squared. So divide every single term by a squared. Okay, I'm going to put that a squared right there, and the reason I'm putting the a squared there is because I want to make sure that cosine squared is by itself. So I have the left side all set. I have the numerator all set. I have this one almost all set. Oh, I can make it all set by factoring out the negative. Okay. So the only thing I need is this right here to become e squared. Okay. Now remember, e is c over a. You can also remember that for the hyperbola, right, that b squared equals c squared minus a squared, right? If I move that over, then I can see that c squared equals a squared plus b squared, and which I have right here, a squared plus b squared. So that right there is going to become c squared. So I'm going to have opposite of b squared, 1 minus, and I'm going to now write this out in front, c squared over a squared cosine squared, and then I say, hey, look at that. That becomes the eccentricity squared times the cosine squared. And there is my verification. Thanks for asking.